Hi there. In this video, we'll continue looking at the multiple choice practice problems from the course description for AP Calculus AB. And in this problem, we're presented with a graph where 5 interesting points are labeled. And we were asked to determine at which of the 5 points on the graph are both of these quantities negative. Is it A, B, C, D, or E? Well, let's dig in. Okay, so regarding the first derivative, we've learned that the first derivative of a function tells us about the slope of a graph. And so we can conclude the first derivative will be positive wherever the function has a positive slope, which means the graph is increasing. Okay, let's sort of reverse that. When is the first derivative negative? Well, the first derivative is negative at any points on the graph where the function is decreasing. Okay, so there's the information that a person needs to know what's going on with the sign of the first derivative, and recall that we're asked to focus on the first derivative being negative. Okay, what about the second derivative? Well, we clean up the picture. We've learned that the second derivative gives us information about the concavity of a graph, and so if second derivative is positive, then we would expect for the graph to be bending up like that. Okay, so do you want to know where the second derivative is positive? Just look and see where the function is concave up. And reverse that. Second derivative would be negative. Whoops, should have written negative there. Negative. Whenever the function is concave down, which means we should look to see where the graph is bending down. It's concave down right there. Okay, and once again recall, we're asked to focus on the points where the second derivative is negative. So let's pop back over to the question now and see if we can choose the right answer. Okay, so number one, we want the first derivative to be negative, so that means that the function should be decreasing. And can we rule anything out based on that? Well, certainly A, it's not increasing there, can't be A. And right over here at E, it's increasing, so it can't be E. D is a little tough to tell. Looks like a small positive number or 0, so probably not D either. Okay, we're down to 50-50 between B and C. We can choose the right answer by determining where the second derivative is negative. And recall that means that the graph should be concave down. Okay, so if we find the point, and I'll clean this up now, we have to choose between these two, which both have negative slopes like they're supposed to. But we want the point where the function is bending down, not where it's bending up. Okay, so the correct answer must be B, because it meets both of the requirements, and C does not. All right, so what is this question doing? Well, from the course description in terms of course goals, one of the things is to understand how derivatives are applied to solve problems. And this could be considered an analysis of curves question. Monotonicity and concavity. Fancy word, monotonicity. That just means that if the sign of the first derivative is positive, then the function must be increasing in a monotone fashion. That means it doesn't vary, it's just always increasing. And similarly, if the first derivative is negative, then we can infer that the function is decreasing in a monotone fashion. Never varies from decreasing. All right, I hope this video was helpful to you, and we'll see you next time.